You have felt it. That sickening bounce when your bolt cutter closes on a hardened padlock shackle and just stops dead, the jaws sliding off the steel like it is laughing at you. Maybe a chip flew off the edge. Maybe the handles flexed and your knuckles cracked together. You paid good money for that tool, and a $5 lock beat it. I took a $20 pair of bolt cutters off my own bench and made them outcut a $200 Swedish set on the exact same hardened bolt. Same steel, same me. One tool crushed it clean, the other skated off. That should not be possible, and for weeks it drove me half crazy trying to understand why. The whole answer traces back to a Japanese blade method that is older than most countries. I am going to hand you the exact fix, and it hides inside a clay tempering technique the swordsmiths were already using more than 1,000 years ago, documented in the Heian period. Here is the part that matters to you. You do not need to buy anything new. The worn, disappointing cutters already hanging in your shed are the ones we are going to wake up. Let me take you back to the moment this started, because I was wrong about almost everything. I had 2 pairs of cutters clamped in my vise, a cheap import and a name-brand pair, and a grade 8 bolt between the jaws. I leaned on the expensive one with everything I had, convinced the price meant power, nothing. Then I closed the cheap one, after I had done one strange thing to it the night before, and the bolt dropped in 2 halves onto the concrete. I actually stood there and stared at it. That single cut is the mystery I spent a month tearing apart. And by the end of this, you will own the whole answer. So let me start peeling it back, one layer at a time, because the first clue is sitting on your tool right now, and you have probably never touched it. Look at the pivot of your bolt cutters. Right where the 2 jaws cross, there is usually a fat bolt with a lock nut, and on better cutters there is a second small screw or an adjustable stop near the head. Most people think that hardware is just holding the tool together. It is not. That is the single most important adjustment on the entire tool, and almost nobody sets it correctly. Here is the puzzle that hooked me. When I measured the jaw gap on my cheap cutters at full close, the 2 edges were not meeting. There was a gap of about 4/100ths of an inch, less than the thickness of a matchbook cover. That tiny gap meant the edges never actually finished the cut. They pinched the bolt, work-hardened the surface, and then slid. The expensive pair, brand new, closed to almost nothing. That was the entire difference in that first test, and it cost nothing to fix. Let me explain the mechanics, because once you see it, you cannot unsee it. A bolt cutter is not one lever. It is a compound lever, which means levers stacked on levers. When you squeeze the long handles, the first pair of levers multiplies your force, and then the linkage at the head multiplies it again before it reaches the jaws. On a common set of 36-inch cutters, that mechanical advantage runs somewhere around 100 to 1, and on the big 42-inch sets, it can climb past 300 to 1. That means the 50 pounds of grip in your hands can arrive at the cutting edge as 5,000 pounds or more of crushing force. But here is what nobody tells you. All that force is useless if the 2 edges never fully meet. If your jaws stop 4/100ths of an inch apart, every bit of that leverage is spent squeezing, not shearing. The bolt gets flattened and hardened instead of severed, and now it is even tougher than before. That is exactly why your cutters bounce off a lock and then do worse on the second try. You are not cutting it. You are forging it harder with every squeeze. So the first fix takes about 90 seconds. You find the adjustment nut or set screw at the pivot. You loosen the lock, and you bring the jaws in until, at full close, the 2 edges just kiss along their whole length with a sheet of paper between them and no daylight showing. Then you snug the lock back down. On my cheap pair, that one adjustment took the gap from 4/100ths down to nearly 0, and suddenly the tool had teeth it never had in the box. I thought I had solved it right there. I really did. I set the gap, I cut a medium bolt clean, and I felt like a genius. Therefore, I got cocky and grabbed a genuinely hard target, a hardened chain link rated for security use, and the cheap cutters chipped a crescent right out of the edge. The gap was perfect. The leverage was there. And the tool still failed. That failure told me the gap was only the first layer. Something about the edge itself, the actual metal doing the cutting, was hiding a second secret. And that is where this stops being about adjustment and starts being about the steel. So let me pull back the next layer, because this is the one that cost me the most wasted money before I understood it. I had always assumed a bolt cutter edge was sharp, like a knife. It is not, and it is not supposed to be. I put my cheap edge and the expensive edge under a loop, and the difference stopped me cold. The premium edge was not a thin razor. It was a stubby, blunt wedge, ground to a wide angle, closer to 60 degrees included, sitting on a body of much softer steel. The cheap edge was ground thinner and more knife-like, and it looked sharper to the eye. My whole instinct was backwards. Here is why the fat, blunt edge wins. A bolt cutter does not slice. It splits by concentrating force into a narrow line and driving a wedge through the metal until the bolt fails in shear. A thin, knife-like edge feels sharp, but it has almost no steel behind the tip to support it. The instant it meets a hardened bolt, that delicate tip has to carry thousands of pounds with nothing backing it up, so it rolls over or snaps off. The blunt 60-degree wedge puts a mountain of steel right behind the contact line, so the force goes into the bolt instead of into destroying your own edge. Now, here is the part that turned the whole thing into a real mystery for me. Angle alone did not explain it either. I reground my cheap edge to that same fat 60-degree wedge, and it still chipped on the hardened chain. I had matched the gap. I had matched the angle, and the expensive tool still won. That meant the answer was not the shape and not the leverage. It was something inside the metal that I could not see from the outside, and that is when I started reading about how the good jaws are actually made and how the cheap ones are made, and the gap between those two processes is where somebody has been quietly taking your money for decades. Because here is the thing they do not print on the packaging. A premium bolt cutter jaw is not hard all the way through. It is hardened only along a thin band at the very cutting edge, up around 58 to 62 on the Rockwell C scale, which is knife and file territory, while the body of the jaw behind it is left much softer and tougher, down around 40. Two completely different hardnesses in one piece of steel. The hard edge holds a bite against hardened bolts. The soft body absorbs the shock and refuses to crack. The cheap cutter skips that step entirely. To save time and cost, the jaws are either left soft everywhere, so the edge caves in, or hardened everywhere, so the whole jaw is brittle, and the edge chips off in chunks the first time it meets something hard. That is the chip I kept getting. My cheap jaws were hardened uniformly, which sounds better and is actually worse, because a fully hard piece of steel has nowhere to send the shock, and it cracks like glass. So the real secret was never the price. It was a heat-treating trick, a way of putting hardness exactly where you need it, and toughness everywhere else, in the same piece of steel. And the second I understood that, a bell went off in the back of my head, because I had read about exactly that idea before, in a completely different world, the world of Japanese sword making. The exact same problem, hard edge and tough body, solved by hand more than 1,000 years ago. Because right now, some of you are thinking this only works if you go out and buy some special premium jaw or some fancy new tool, and that the beat-up cutters in your garage are too far gone. This next part is built specifically for you, the person with the rusty, sprung, chipped-up pair that has been living on a nail in the shed for 10 years. I am talking to you now, because you are the one who is going to get the most out of this. Here is the truth. Your worn cutters are actually the perfect candidate, and here is why. That soft or uniformly cheap steel in your jaws is exactly the blank slate this technique needs. You are not fighting a factory heat treatment. You get to put the heat treatment in yourself, by hand, right where you want it, using nothing more than a propane torch, a bucket of water or oil, and a bit of ordinary clay or even plain mud from the yard. No forge, no furnace, no milling machine. Everything you need probably fits on the bench you are looking at. Let me walk you through the plain tool version before we get to the deep secret, so you have a usable upgrade even if you stop right here. First, you take that worn edge and you clean it up on a bench grinder or with a file, and you set it to that fat wedge, around 60 degrees included, not a thin knife edge. Go slow, dip it in water often, and do not let the steel turn blue, because if it changes color from the grinding heat, you have already ruined the temper before you even start. Second, you check that pivot gap we talked about and bring the edges into a true kiss at full close. Now you have geometry and leverage on your side. For a lot of everyday cutting, soft wire, mild bolts, fencing, that alone will make your tired cutters feel brand new, and it cost you nothing but 20 minutes. But if you want them to eat hardened steel, if you want that cheap pair to shame a tool that costs 10 times as much, you have to do what the swordsmiths did. And that is the layer I have been holding back, the one that finally solved it for me at 2 in the morning with a torch in my hand. Let me tell you what I found, because it reads like buried treasure, and it is completely real. That connection is the key to the whole thing, and I am going to give it to you in full. But before I do, I want to point you toward something that pulls all of this together. If this kind of deep dive into what tools are actually made of and how to bend that knowledge in your favor is the way your mind works, I wrote a book called Tool Mind and its companion volumes, Steel Instinct and Tool Master, exactly for you. These books go through the same process you are watching right now, stripping away the marketing, reading the metallurgy, and handing you the specific knowledge that turns a bench full of cheap tools into something that outperforms gear costing 10 times as much. You can find the details in the description below. If this video resonates with you, the books will feel like a direct continuation of it. Now, back to the swordsmiths, and the exact method that finally cracked this wide open for me. The Japanese swordsmiths had the exact same nightmare we have with bolt cutters. They needed an edge hard enough to hold a razor bite, but a blade hard all the way through would shatter on impact. Their solution has a name. It is called yaki ire, the hardening, and the heart of it is a clay coating step called tsuchioki. And this is not folklore. The technique is documented in blade traditions going back to the Heian period, more than 1,000 years ago, and the physical proof is still visible on every real Japanese blade as the wavy temper line they call the hamon. Here is what they actually did, and here is why it is the answer to your bolt cutter. The smith mixed a slurry of clay, charcoal powder, and ash, and he painted it onto the blade in 2 different thicknesses. Along the very edge, he left the coating extremely thin or bare. Along the spine and body, he packed the clay on thick. Then he heated the whole blade to a critical temperature, glowing, and plunged it into water. Now watch what that clay does, because this is the entire trick. The bare edge, with no clay, is exposed directly to the water and cools almost instantly. That flash cooling locks the steel into a hard structure called martensite, which is the hardest thing plain carbon steel can become. The thick clay on the spine acts like a blanket. It slows the cooling of the body so that steel cools gently into a soft, tough structure. One quench, one piece of steel, 2 completely different hardnesses, placed exactly where the smith wanted them. Hard where it cuts, tough where it takes the shock. That is the same 58 to 62 Rockwell edge on a 40 Rockwell body that the expensive bolt cutter is charging you $200 for. Except The swordsmiths were doing it by hand with mud and fire 12 centuries before anybody sold a bolt cutter. The industry did not invent this. They just quietly stopped doing it on the cheap tools and let you believe hardness came from the badge on the handle. So here is exactly how I brought that 1,000-year-old method to a $20 pair of bolt cutters on my own bench, and how you do it this weekend. Start by removing the jaws from the cutters if your design allows it, or at least back the pivot apart so you can work one jaw at a time. Clean the steel down to bare metal along the cutting edge. Now mix your clay. You do not need anything exotic. I used ordinary potter's clay thinned with water to about the thickness of pancake batter, with a spoon of wood ash stirred in, and that works beautifully. But even packed mud or refractory furnace cement will do the job. The magic is not the recipe. The magic is the two thicknesses. Paint the clay onto the jaw, and here is the crucial part. Leave the last 1/16 of an inch right at the cutting edge completely bare, clean steel showing. Then build the clay up thick, 1/8 of an inch or more, over the body of the jaw behind the edge and around the pivot area. You want a clean line between bare edge and thick body, because that line is where your hardness will change. Let the clay dry completely, slowly, until it stops looking dark and wet. If you rush it and it cracks off, you start over. Now the heat. Take your propane or MAPP torch and heat the bare edge of the jaw evenly until it glows a bright cherry to orange, somewhere around 1400 to 1500 degrees Fahrenheit for common carbon steel. The way the old smiths judged it without a thermometer is a trick you can use right now. You hold a magnet near the steel as it heats, and the exact moment the steel stops sticking to the magnet, it has reached the critical temperature it needs to harden. That non-magnetic point is your green light, and it costs you nothing but a fridge magnet. The instant that edge is glowing and non-magnetic, quench it. Plunge the jaw edge first, straight down, into a bucket of warm water or, better for most steels, into oil. Edge first, and hold it steady. Do not swirl it wildly. The bare edge hits the liquid and freezes into hard martensite in a fraction of a second, while the clay-blanketed body cools slow and stays tough. You have just done tsuchioki on a bolt cutter. If you used water, and the steel is high enough in carbon, you may even see a faint cloudy line appear along the jaw where the hardness changes. That is your own Hummin. That is the same line that proves a katana is real. There is one more step, and skipping it is the mistake I made the first time, which is why I chipped an edge even after I hardened it. Fresh out of the quench, that martensite edge is glass hard and brittle, so full of stress it can crack if you look at it wrong. You have to temper it. Put the whole jaw in your kitchen oven at about 400 degrees Fahrenheit for 1 hour. Then let it cool in still air. That gentle reheat pulls a little bit of the brittleness out and trades a hair of hardness for a lot of toughness. Now your edge is around that 58 to 60 range, hard enough to bite hardened bolts, tough enough to survive the shock. Reassemble. Reset your pivot gap to a true kiss, and you are holding a tool that will genuinely outcut factory sets costing 10 times the price. I want to be straight with you about why this feels like a secret when it should be common knowledge. Every single piece of this, the compound leverage, the fat wedge angle, the differential hardening, the clay coat, all of it is real, proven, published metallurgy, and 1,000-year-old craft. None of it is hidden in a vault. It is hidden in plain sight, split up across a sword-making tradition most tool owners never read, and a heat-treating process the budget factories quietly delete to save a few cents per jaw. Somebody figured out that if they left the hardening uneven and the geometry wrong, your cheap tool would fail, and you would blame yourself and go buy the expensive one. The knowledge did not disappear. It just stopped being handed to you. But now let me close the last little gap in the mystery, because there is a detail even beyond the clay that separates a good result from a spectacular one, and it is the thing that made my cheap pair actually beat the Swedish set instead of just matching it. It is the direction of the shear. When I studied how the premium jaws were ground, I noticed the two edges did not meet perfectly flat against each other like scissors closing on the same plane. They were ground with a very slight bypass, an almost invisible offset, so that as they close, the two hardened edges slide past one another by a hair, shearing the bolt the way tin snips shear sheet metal, instead of crushing it head-on like a nutcracker. Crushing needs enormous force. Shearing needs far less, because at any instant only a tiny slice of the bolt is being cut, not the whole cross-section at once. On my cheap cutters, the jaws met dead flat, and tried to crush the whole bolt in one go, which is why they needed so much force and bounced off hard steel. So, after I hardened the edges, I took a fine stone and put the faintest bevel on the inner faces, so that, as the tool closes, one edge leads the other by just a few thousandths of an inch, and the cut peels across the bolt instead of hitting it all at once. That single refinement dropped the effort to cut a hardened bolt by more than half, and it is the last piece that turns a good home job into a tool that feels frankly illegal for what it cost. So there is the whole solved mystery laid out in one line. A cheap bolt cutter fails not because the steel is cheap, but because three things are wrong that cost nothing to fix. The pivot gap lets the edges miss each other. The edge angle is too thin to survive the load. And the steel is hardened wrong, either soft everywhere or brittle everywhere, instead of hard at the edge and tough in the body, the way the Heian swordsmiths learned to do it with clay and fire more than 1,000 years ago. Fix the gap, fatten the wedge, clay temper the edge, add the shearing bypass, and the $20 tool crushes the $200 one. Every time. I tested it more ways than I can fit here. I cut hardened bolts, security chain, thick fence wire, and a padlock shackle that had beaten the tool in its factory state, and the rebuilt cheap pair went through every one of them clean, while the untouched premium set was already showing edge wear. The total cost of the upgrade was a bag of clay I already had, a tank of propane, and an afternoon. That is the number that still gets me. An afternoon of work replaced a lifetime of buying replacement tools. And here is the part I keep coming back to. This never was about bolt cutters, not really. It is about the fact that the difference between a tool that fails you and a tool that feels unstoppable is almost never the price tag. It is knowledge, a specific handful of it, that used to travel from craftsman to craftsman and somewhere along the way got left out of the box on purpose. You just took it back. That edge in your hand does the impossible thing now because you understand what the steel is actually doing, and nobody can sell you that twice. You are the kind of person who would rather understand a tool than be sold one, or you would have clicked away 10 minutes ago. That is the whole reason I do this. I would rather hand you the method than the receipt. So do one thing for me. Tell me in the comments whether you are going to try the clay tempering yaki ire trick on your own worn cutters, and more than that, tell me which target you are going to test them on first, the hardened padlock, the security chain, the grade 8 bolt, or something meaner that has beaten your cutters before. I read those, and I want to know what beat you, because that is usually where the next discovery hides. Tell me where in the world you are watching from too, because this old knowledge has traveled a long way to reach your bench. If tearing tools apart to find out what actually makes them work is your idea of a good weekend, then you already belong with the people who follow along here, the ones who refuse to be fooled by a price tag and would rather rebuild than replace. Stick around, because the next tool I am cracking open is the humble angle grinder, and I found a way to change one small thing at the disc that nearly doubles how fast it cuts without a single extra watt of power. That one honestly surprised me more than this did, and I cannot wait to show you what is hiding in there. Before you go, one more thing. This video gave you the overview. But the full clay tempering and pivot tuning method, step by step, is waiting inside the Workshop Guild. Once you're in, Ask me your own questions, and a real person, me or my team, answers you, never a machine. You'll belong right alongside fellow tinkerers just like you. Just point your phone's camera at the code on screen. Cancel anytime with one click. Come join me.